Hi, sixth grade. Hopefully, everybody's doing well today and had a great weekend. Today, we're going to start on a new lesson. That's going to be Chapter 10, Lesson 7 Theoretical and Experimental Probability. So, let's figure out how we're going to find the notes of that. Go up into your Google Classroom, click on your classwork. We're going all the way down here to 10. Click on Chapter 10, and down here, you will see chapter 10, lesson 7, the student completed notes, and that is the notes that we're going to be going over today. So let's take a look and let's see what we have here. So, chapter 10, lesson 7, theoretical and experimental probability. So, as we know, we talked about in the last lesson there what probability is, how it is written. As you see, this capital P here, okay, that means the probability of some type of an event. The event is in parentheses here. And we typically write that as a subscript, which is just below the letter P. So the probability of an event that is occurring. So let's see what it says here. It says, in a uniform probability model, each outcome has an equal probability of occurring, which means everybody has the exact same chance. For example, some carnival games involving a spinning wheel to win a prize. If each prize is equally likely, you can use a uniform probability model to calculate your chances to win a particular prize. So think about this. If I had, it's not going to be very good. If I had a circle here, okay, and this is our wheel. That's a terrible circle there. And I divide it up into 4. And let's say this was a perfect a circle here. That means this piece of the pie is equal to that piece of the pie, which is equal to that piece of the pie, which is equal to that piece of pie, which means they're all equally likely. That's what we mean by a uniform probability, a model. Now let's talk about the two basic types of probability. We have a theoretical and experimental. So let's just go with the theoretical. Let's see what that means there. Now, in theory, we expect something to occur. So what we mean here, theoretical probability is based on uniform probability. Okay, what should occur when conducting a probability in an experiment? So what we mean by that, if I have a coin, one side is heads, one side is tails. What we are figuring is that in theory, if we were to flip that coin 100 times, 50 times it should come up heads, 50 times it should come up tails. In theory. But in real life, does that occur? No, not at all. That's what we call experimental probability. So in theory, we do not do an experiment. It's just what we believe to be a true. But to actually see what is actually true, we do the experimental probability, which means, hey, we do an experiment to see what we actually get. So this is based on relative frequency. We're going to be making a frequency a table here. So what actually occurs during such an experiment? So that's what we're looking at here. What is actually going to occur? If the number of trials is very small, there can be a wide variation in the results. So what we're saying here, hey, if I only did this twice, we're not going to get a good experimental probability. But if I flip a coin 100 times, hey, that's going to give me a realistic view. If I flip it 1,000 times, even a better view it's going to give me of how many times heads is going to come up and how many times tails is going to come up. So let's see what we have here. Let's scroll down here. So it says the table shows the results of an experiment in which a number cube was rolled. We're just talking about a die, which has numbers 1 through 6 on it. It says find the experimental probability of rolling a 6. Okay, that's our event, the probability of rolling a 6 for this experiment. Then compare the experimental probability with the theoretical. Okay, so let's start here with the experimental probability that we have here. So basically they did the work for us. Somebody rolled the dice. If I count all these up, the 4 plus 6 plus 2 plus 8 plus 3 plus 9, that gives me a total of 29 rolls. And 1 came up 4 times, 2 came up 6 times, 3 came up 2 times, 4 came up 8 times, 5 came up 3 times, and 6 came up six times. So we want to know what is the probability of rolling a 6. Okay, we're dealing with the experimental. So how many times did a 6 come up? So if we look at the 6, it came up 6 times. Okay, over our total. So divided by 29. Now, you're going to use your calculator. You're going to divide that, and you're going to get, pull up my handy dandy calculator here. So if I did my 6 divided by 21, I'm going to get a, by 29, 6 divided by 29, I'm going to get 0.20689. Well, let's round it to the nearest percent. Okay, so I would round that to 0.21, which is 21%. So it should be approximately 21% there. So that's how we get our approximate 21%. Now, that's our experiment because this was our experiment over here. Now, in theory, which means we're not going to do an experiment. In theory, each of the numbers has an equal chance. So the probability of getting a 6, well, there's only one 6 on a number cube. That's here our 1. And there's a total of 6 of the numbers on our cube. So it's 1 over 6. So if I plug that into the calculator, I get 1 divided by 6 equals 0.1666666. So we were to estimate that to our nearest percent, that would give us 17%. So what can we say here? We can say rolling a 6 in the experiment occurs more often than expected. Okay, so that's what we expect here. Okay, rolling a 6 in doing our experiment will occur more often in an experimental probability than in theoretical. So let's take a look at this next one here. It says a coin was tossed 40 times and heads came up 18. Find the experimental probability of getting tails. Now they want us to look at tails, not heads in this experiment. Then compare the experimental probability with the theoretical probability. So scroll up here. So we know that if we flip that coin 40 times and we got heads 18 times, I do 40 minus 18, okay, which gives us our 22. So we can say tails came up, the probability of getting tails. So P subscript 2 is 22 out of 40. We can reduce that to 11 over 20. And 11 divided by 20 is 55%. So in an experimental, it's tails will come up 55% of the time. In theory, now we only know there's 2 choices. There's either heads or tails. Tails is one of those choices. So that's why tails, there's a single chance of getting it out of a total of heads or tails, which is 2, which comes to be 50%. So it says here, getting tails in the experiment occurs more often than expected, because the expected is going to be 50%. When in reality, it's going to be 55%. That's what we did with our experiment. So let's turn over to the next page. Okay. Now, making predictions. So here we go here. Let's see what we have here. So it says the table shows the results of a survey that asked 200 teens what they would be doing if they were not online. So out of a similar group of 450 teens, predict how many would listen to music. Okay, so as you see here, we have watch TV, listen to music, physical exercise or activities, read. Don't know what that says. Withdraw, maybe. I'm not exactly sure. And others. Okay, so here are the responses. 50 said, hey, I'm going to watch TV. 52 says, hey, I'm going to listen to music, and so on and so forth all the way down. So as we look at this, the probability of getting music is going to be 52 over 200 because we surveyed 200 teens. So 52 over 200, if we do that on our calculator. So we go 52 divided by 200. That gives us 0.26, which we convert to 26%. So we figured that 26% of the students out of these 200 are going to listen to the music. So if we're saying, hey, what if we had 450 of those kids? Okay, so our total here, so if we look, our total teens that we're talking about now is 450. So all we're doing, we have our N, that's our number of teens. We do not know that are going to listen to music out of the 450, but we know this is going to be 26 over 100, which is 26%. So all we need to do is just cross multiply here. You go N times 100 is 100N equals 450 times 26 is 11,700. Now, in order to get this answer, I'm going to divide this side by 100 and this side by 100. And as you see, these zeros cancel out. And the answer is 117 teens. So what we expect is 117 teens out of the 450 that we're talking about now will be listening to music. So let's take a look here at the next one here. So Mrs. Newman surveyed her class to see which sports they preferred to watch. It says 44% preferred football, 28% preferred basketball, 20% preferred soccer, and 8% preferred tennis. Okay. Out of 560 students, in the entire school, how many would you expect to say they preferred watching basketball? Okay, so we know that basketball represents not 28%. I'm not sure how we got that here. Yes, it is. I'm sorry. 28% for the basketball. My bad there. So 28%. I was looking at that 20 right there. So 28% over 100. That's the same. 28 over 100. It's the same as 28%. Now we want to figure out how many like basketball. That's our N. Our 560 represents the total students in the entire school. That's a small school. We have basically 2,000. No, we have about 1,200 kids. So we have more than half that amount. So all we're going to do is cross multiply here. 100 times N is 100N. 560 times 28 is 15,680. So in order to solve this now, we are going to cross multiply. We cross multiplied already. We are now going to divide both sides by 100 to get the N all by itself. So divide both sides by 100. Here and here, and we get to be N to equal 156.8 students. So we're going to estimate that into 157 students. So basically out of that 560 students that we have, approximately 157 students prefer watching basketball. So we should be good to go with that. If you have any questions, please rewatch the video. And if you are still concerned, please shoot me an email and I'll go over some more of the information with you. Make sure you start working on your homework. Take your time, use a calculator, refer to your notes, always be looking at your notes. If you have any questions with that, let me know. Other than that, guys, tomorrow we're going to be starting 10-8. That will be the last topic of this chapter, and we'll finish that up. Other than that, guys, have a great day. Talk to you later. Bye-bye.